It all begins with a rock. Not particularly remarkable, perhaps even mundane. A chunk of earth, silent and unassuming. Yet in the right hands, or the wrong ones, this rock becomes the catalyst for the single most destructive force humanity has ever unleashed. This is the hidden, explosive journey of how uranium is enriched and how it becomes the heart of a nuclear bomb. Most people have heard of uranium. You might know it powers nuclear plants, lighting up cities and fueling submarines deep beneath the ocean. But very few truly understand how this element, buried quietly under ancient soils, is transformed into a weapon of incomprehensible power. The process of enriching uranium is shrouded in secrecy, guarded by governments, and fiercely debated on the world stage. It's not just a scientific procedure. It's an equation of power, a geopolitical chess game, and a silence heavy with responsibility. Every nuclear bomb ever detonated started the same way, with atoms manipulated to the very edge of physical law and human morality. To understand uranium enrichment, you first need to know the element itself. Natural uranium, as it is dug from the earth, is composed of two main types of atoms, or isotopes. The first, uranium-238, makes up more than 99% of what's found in nature. It's stable, predictable, and for the most part, useless for weapons. The second, uranium-235, is the true prize. Rare, unstable, and capable of sustaining the rapid chain reactions that make both nuclear reactors and bombs possible. But U-235 is vanishingly scarce, less than 1% of natural uranium. For uranium to be weaponized, its U-235 content must be artificially increased from just 0.7% to over 90%. This is called enrichment, and it is among the most technically demanding and closely monitored processes in the world. The technique most widely used today is called gas centrifugation. The process begins with conversion. The solid uranium ore is chemically transformed into a highly reactive gas known as uranium hexafluoride, or UF6. This gas holds both isotopes mixed together, indistinguishable to the naked eye. Next comes centrifugation. The UF6 gas is injected into long, vertical cylinders called centrifuges, which spin at astonishing speeds, up to 100,000 revolutions per minute. Under these extreme forces, the slightly lighter U-235 molecules tend to collect nearer the center of the spinning gas, while the heavier U-238 molecules are forced toward the outer edge. But the difference between them is almost imperceptible, so the separation is only partial. To reach usable concentrations, the process must be repeated thousands of times. This is achieved by connecting thousands of centrifuges in series known as a cascade. With each pass, the proportion of U-235 increases a little more, step by painstaking step. For civilian purposes, such as fueling nuclear power plants, uranium is enriched only to about 3 to 5% U-235. At this level, it delivers immense energy but is not suitable for weapons. To cross the threshold into military-grade material, enrichment must continue relentlessly until the proportion of U-235 exceeds 90%. This is the zone of immediate international alarm, the red line that triggers scrutiny, sanctions, and sometimes the threat of war. But the science, as sophisticated as it is not the real barrier. As Dr. Siegfried Hecker, former director of Los Alamos National Laboratory, explains, the knowledge necessary to enrich uranium is no secret. The challenge is technical. But once a nation masters the process, building a weapon is a matter of time and political will. The technology is not magic. It is engineering, patience, and ambition. Jeffrey Lewis, an expert in nuclear non-proliferation, adds a warning. Detecting unauthorized enrichment is a race against the clock. When a country crosses the 90% purity mark, we are one step away from a nuclear arsenal. The stakes are global, and the timeline is always urgent. So, the question that keeps world leaders awake at night is simple, terrifying, and unresolved. Who, right now, is enriching uranium? And for what purpose? In a world where technology and political tension walk side by side, knowledge itself can be more dangerous than the bomb. The tools and techniques for enrichment are no longer the exclusive domain of superpowers. As the barriers to entry lower, the risks multiply and the margin for error shrinks. Enrichment facilities are sprawling, high-security complexes. They hum with the relentless spin of thousands of centrifuges, consuming vast amounts of electricity and operating under the constant gaze of satellite surveillance and international inspectors. The International Atomic Energy Agency works to monitor and verify the peaceful use of nuclear technology, but their reach is not absolute. Secrecy, deception, and national pride often cloud the true picture. The decision to enrich uranium beyond civilian levels is never just about science. It is a declaration of intent, a message to allies and adversaries alike. For some nations, it is a deterrent, a shield against perceived threats. For others, it is a bargaining chip, a way to extract concessions or project power on the global stage. But for all, it is a step that cannot be taken back. Once the knowledge and infrastructure exist, the line between energy and weapon, promise and peril, grows dangerously thin. The story of uranium enrichment is not only about physics and chemistry, it is about secrecy and trust, hope and fear. It is about a world that has seen the devastation of Hiroshima and Nagasaki and has lived for generations under the shadow of the mushroom cloud. And it is about the choices, quiet, momentous, often invisible, that shape the fate of nations. In the end, it is not the bomb itself that changes the world. It is the decision to build it, to use it, to let knowledge become power and power become destiny. The rock, silent and unremarkable, is only the beginning. What we do with it, how we control it, share it, or unleash it, determines everything that follows.